This is section 7.3, complex fractions. This section sounds hard, the problems look hard, but they're really easy to deal with. A complex fraction is a fraction that contains fractions. Now you might be wondering why anybody would want to even create something like this. Well, sometimes we have formulas that are fractions, and sometimes we'll need to plug fractions into that formula. So we do really know we need to know how to deal with fractions within fractions, okay? There are two methods for working with these, and I mention that only because help me solve this or view an example might show you another method. If the homework says to solve it using method 1 or if it says method 2, just don't worry about that. I'm going to show you the method that is easiest for most people to understand. If you look at the other method and you want to use it, you're free to do so, okay? What we want to do is you want to change your main fraction bar into a division sign. Okay, so it becomes this fraction divided by this fraction. When you are writing things out, I strongly suggest that you exaggerate how big your main fraction bar is, because it can get very confusing if they all appear to be roughly the same size. This is the same thing as k plus 1 over 2k divided by 3k minus 1 over 4k. Now this is a problem we've been working. What you want to do is you want to factor everything as much as possible, and nothing here factors. So I'm going to put this k plus 1 in parentheses because I've looked at it. It doesn't factor. It has to work as a unit from now on. And the same thing happens with the 3k minus 1. There's no addition or subtraction down here, so we don't have to do anything. What we're going to do is we're going to keep the first fraction, change it to multiplication, and flip the second one. Keep it, change it, flip it. That's exactly the same as what we've been doing. Times 4k over 3k minus 1. Now we look for cancellations, and we don't have anything up and down, but if you look on this diagonal, we have a k in both of them, so we could lose the k. And if I divide the 2 by a 1, 2 by a 2, I get a 1. Divide 4 by 2, and I get a 2. These do not cancel out, so multiply straight across. You have 2 times k plus 1 over 3k minus 1. You can keep this in parentheses if you want to, or since it's not being multiplied by anything and you're already done, you can drop the parentheses on the bottom. You can't drop them in the top because you have a multiplication. This is your answer. Okay, so let's try this one. I have 3y squared x cubed over 8 divided by 9y cubed x to the 4th over 16. There is no addition and subtraction in here, so there's no factoring to do at all. All I'm going to do is I'm going to rewrite this as a division problem. All right, now keep it, change it, flip it. This will be 3y squared x cubed over 8 times 16 over 9y cubed x to the 4th. Okay, so let's look for some cancellations. On this diagonal, I can divide both of these by an 8, and that would give me a 1 there and a 2 here. Now we have a lot going on here. If I divide this by 3 and this by 3, I'll have a 1 here and a 3 here. Here I have 2 y's, here I have 3 of them. These 2 cancel out 2 of these, and so I will have 1 left. This is 3 minus 2, which gives you the exponent of 1. And very similar here with the x's, x cubed, x to the 4th. Here there are 3 of them. Here there are 4 of them. So these 3 cancel out 3 of these, leaving 1. Okay, so this is a little bit crazy. What do I have left? All of this is gone. All of this is gone. So my answer is 2 over 3yx. Make sure your fraction bar extends over far enough. You don't want anything slipping out from under the fraction bar. Okay. So this one's a little bit more difficult, but it's still still a complex fraction. I'm going to take this top and divide it by this bottom. So just a rewrite, 10x minus 5y over 12 divided by 2x minus y over 6y. Double checking that I haven't made a mistake on the recopying, and I think I'm good. So now I need to factor everything as much as possible, and I'm just going to factor these two above. I can factor a 5 out here, and that leaves 2x minus y, and this one does not factor. Okay? So this is the same as this. I just factored it above so I can save a little bit of paper. This is a division, so we keep it, change it, flip it. So 5 times 2x minus y over 12. I'm keeping this one, I've just factored the numerator, times 6y over 2x minus y. Now look for cancellations. I have a 2x minus y in both of these, so that goes. If I divide this by 6, I get a 1. Divide this by 6, and I have a 2. So what do I have left? 5y over 2. And that's my answer. Last problem. This one is trickier. All the ones we've had before have been a single fraction in the top, a single fraction in the bottom. Here we have an addition of fractions in the top and a subtraction of fractions in the bottom. You may remember when we talked about order of operations that the fraction bar operates as a grouping symbol, and we have to simplify the top and then simplify the bottom before we can divide. Now when we go to switch it over to this kind of notation, that kind of division, we still have to make sure that we do this top first and then the bottom first before we divide. The way we show that is to put those in parentheses. This still says we have to do the addition and the subtraction first, and then we divide. Okay? Now, to do these, we need to get a common denominator. And the good thing is that we have exactly the same fractions. So once we rewrite the first group, we know how to rewrite them the second time. My common denominator is going to be xy. So I need to rewrite these with xy in the denominators. And like I said, these happen to be the same fractions, so we can just do the thinking once. If they were different, we would have to find a separate common denominator. Okay? To go from here to here, I multiply the denominator by a y, so I need to multiply the numerator by a y as well. It's 3y. So this one is also 3y. Here, I multiplied the denominator by an x, so I have to multiply the numerator by an x. And that happens on both of them. Now go ahead and combine these. This is 3y plus 3x over xy divided by 3y minus 3x over xy. Let's factor those numerators. I can factor a 3 out here. 3 times y plus x over xy divided by, again, factor out a 3, y minus x over xy. Okay, now keep it, change it, flip it. This is 3 times y plus x over xy. Change to multiplication and flip this one, xy over 3 times y minus x. Now that it's multiplication, we can look for cancellations. And on this diagonal, we have a 3 in both of them. Here we have an x and an x, a y and a y, so they both go away. So I have 1s here and here. These two are not the same. Yes, we have the same variables, but they are not the same. This one's an addition, this one's a subtraction. And these would have to cancel out as a unit, and they don't. So our answer is y plus x over y minus x. You can keep the parentheses around them if you want to. Again, just make sure that this whole thing is in the denominator. Don't write your fraction bar like that because it gets very confusing and causes problems much later. Okay, that's the end of this section.